Yo, what up guys, so in today's video what I want to do is continue with networking into part 2. Now I'm planning to make this video about switches, devices, basically devices used in networking. What are the benefits, what are the purposes of it, what are the drawbacks and stuff like this. And that's what you basically you'll be taught this in networking devices, networking classes anyways, or whenever you are doing in IT. Just what I mean by this is just whenever you're going to work in IT, you need to know this, because these are the basics. I'm going to show you some like the configurations as well and how things work. Now, if you would like to basically learn how to use Packet Tracer, because this is the program I'm using, this is the currently program you'll be using regardless, because it's one of the best programs out there and it's very well developed. Also, it's free, you don't have to pay anything, you just need to set up your own account on NetAcad and Skills for All, which I have showed you before. And make sure to, now on the screen somewhere, I think around that right corner, you should get a link to a playlist of Cisco Packet Tracer, which I briefly and maybe not as detailed because they were my first videos. I didn't really have a good microphone at the time, so I didn't really want to talk too much because microphone was bad. I wanted to show you more. Now because I have a good microphone, I can talk more and show you more, and overall I am a better sort of person in terms of recording. So as I said, yep, so basic networking devices. Networking devices, obviously they're very, very important because without knowledge of networking devices and without the devices, we couldn't connect these devices together, right? We couldn't make a network because, as I said before, 2 devices or more make a network. Your at-home router is not the same as a router, like a networking router. Your actual home router, like the things you plug in stuff into and you connect to, it's an actual switch, right? So basically, the first thing I'm going to show you, I'm just going to show you in the left corner. As you can see, there's some devices. I'll zoom in on the video, in the editing software, what these devices are. So basically, first thing we have is network devices, and we have, but I'm going to start with hubs because that's the shortest thing to actually explain. So basically, hubs. There's a PT hub, I don't know what PT hub stands for, and PT repeater. These are 2 different devices. Hub is basically something that, it's basically a switch, but it's much slower, much cheaper, and you can, I think you can get a hub for £100, something like that. It operates on IP addressing, which makes it sort of slower. It's very, very out of not fashion, I was going to say fashion. It's not really used now because we have switches. Switches are much faster and they operate on something called MAC addresses. In a second, I'm going to explain that. Just go a bit slower now, right now, and let me go. And on the screen here, I'm going to show you some benefits and drawbacks I did mention because I sort of, obviously I cannot remember everything. I usually focus on routers and switches because hubs are not really used, so you don't really need to be, too educated about it. But basically, hubs are devices that you just basically, as a switch, you connect devices to it, and basically they have less ports. I think they have like maybe 5 usually, I think, I'm not sure. They have usually like 5 ports and you connect to it. It's very cheap, you can get one for £100, and it's the sort of the way you should possibly go if you're going to make a really, really small network. Because if you, example, you want to, for example, I want to have 3 computers connected to basically, connected together because I want to maybe access files from that computer. Maybe I want to drag some files, maybe that's a server, whatever, right? So you should use a hub. It's not as fast as a switch, as I said, but still do the job, right? So basically, hubs are the devices that you should use for really, really small networks, optimum, like maximum up to 4 devices or 5. Now, as far as I can remember, there's no really too many sort of drawbacks of using hubs. It's just maybe not as fast and it has less ports and possibly functionality as a switch. So let's go over to repeater now. Repeater is something that you use because as the cables are go along, right, the further, like example, if you were to have a 3-story building, right, 3 floors building, and you, for example, have to obviously align the cables, and you have to, for example, we have to go for maybe, I don't know, couple meters of cable, and there's because this cable basically sends signals, right? The data you send for the cabling is data, the waves. So basically the waves, obviously, the longer they go, they lose the signal, which means obviously it's I think like electricity. same thing. As the sort of voltage gets smaller, you need to sort of extend it. If I'm not wrong, you have to. It's like Minecraft Redstone. Sorry, I meant to like Minecraft Redstone, right? As the signal gets weaker, you have to extend it with the repeater, right? So this is the same story. If you have a horizontal signal here, and by the way, you can see the interfaces with this. You can play around with this as well. I've never actually used repeaters with hubs, more of switches and routers. Yeah, so basically, this is the repeater. Now, repeater is basically, as I said, is to use to extend and make the signal stronger, because as the wavelength goes along, I'll try to paint it for you guys, if it's possible. Let me just switch the screens, paint. Okay, there we go. So basically, as the signal goes along, it goes something along this. Signal's going, bam. And then we need to use a repeater to make the signal go bam, 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 bam. Repeater, bam, 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 bam. And that's the same thing. That's how the signal goes. And this is what we would use, obviously, to make the signal stronger. We use a repeater. So you would use a repeater here and here to make, obviously, the signal better and stronger. And to be honest, that's it. You wouldn't really, repeaters, I'm pretty sure they're very cheap because it's just a hub, I think. Or you can use a hub as well to extend the signal, because they have basically, I think, hub and repeater sort of the same thing. But I think hub is just, yeah, so as you can see, hub only has like 6 ports and a repeater only has basically 2 ports. So it matters what you would do. Maybe if you want to connect something along the way, you would use a hub. If you want to just extend the signal, you would use a repeater. Okay, so that's sort of done for this. So the next obvious devices we have is something called a switch. Now, switches are one of the most advanced devices currently used in networking, because they operate on something called MAC addresses. Yeah, so I was right, it's a media, that's what it stands for. MAC address is it's a physical address of the computer. Now, in IP networking, right, IPv4 at least, IP physical, as you can see, actually I'll show you in a second. As you can see, this is logical. Logical means actual, like like Cisco packet tracer, right? The actual layout of the network, but not physically. And the physical is just obviously how the computers are set up. For example, you have a room. For example, let's start this. You can actually use this packet tracer for me to show you. Made my wiring cabinet. There we go. So this is can we go back? So as you can see, this is the actual physical layout of this, for example. So like, for example, this is the entrance. Yeah, so you come in here. This is like the example. This is like office. I don't know, office 1, office 2, office 3, office 4, and this is like the wiring cabinet, and this is the physical layout, right? So now the logical address is basically IP address, and physical is your MAC address, right? The difference between them is obviously a MAC address is different. MAC address is 48 bits and IP address is 32 bits. IP addressing is in binary, and MAC addressing is in hexadecimal. Also, Cisco switch is a layer 2 device. What that means is it uses physical address. As I said, it uses physical addresses. For example, I can show you on my computer. Actually, I won't show you that. So basically, the MAC addresses would look something like this. Let me just move, because for some reason, packet tracer, the OBS doesn't recognize this window, and I have to switch to my monitor. Yeah, so I like IPv6 actually. What the fuck am I doing? ipconfig/all. There we go. A physical address. This is the physical address. Can I make this bigger? Obviously not. So a physical address would look something like this. So it's 00A.41T9.953. And those are the physical addresses. That's what the switches use. And as I showed you before, switches have about 24 ports that you can connect stuff to. So we're gonna use a PC. We're gonna connect these things together. Obviously now, because you cannot connect computers together, plus it's not a very good thing because then you would have to control. If you were to do this in a network, you would have to, well, you can't really, right? Because computers only have one port. And there's also cabling, which I'll show you in a second. I'm gonna have to go on the internet and show you a diagram to make stuff easier for you. So basically, as you can see, there's only fast Ethernet. I'm pretty sure you could possibly put another one, but there's no really a sort of reason why you would do that, why you would extend your network card in a computer. Right, so as you can see, this is a switch, and these computers are connected to the device, to the network. So basically, now let's just speed this up. So okay, there we go. Let me just actually get a server as well, so I'm showing you a wee network. Let's use cable. There we go. Let's sub DHCP as well. Actually, I'll set this up and I'll come back to you in a second. Now, I've set up a wee network. Now, I just forgot to mention in the last video, if something says a pipa, right? For example, as you can see, I disconnected the network from the server, which means now if I was to set DHCP, it will say something called a pipa. Now, I cannot remember exactly what a pipa stands for. Now, it's not might even work for this case. Now, whoa, it's just a wee pop-up. It will say a pipa. DHCP request not successful. A pipa has been assigned. Whatever it says, I don't fucking care. Right? Whatever. What that means, a pipa is something. It's basically Windows default IP addressing system, right? So if you can, for example, you send a request to the server and you cannot get an IP address from the DHCP server, and you get an IP address start with 169. Actually, I'll actually show you. Let's just turn off the DHCP. There we go. Remember, as I said, if you do DHCP, you need to turn service on DHCP because it's by default it's turned off, and the DNS as well, right? Remember, so these things need to be turned on. So I've turned it off now, and as you can see, if I go to the IP configuration and try to get a DHCP requesting IP address, and I should say, a second, yep, DHCP failed, a pipa is being used. A pipa is, as I said, I can't remember what it stands for, whatever, it doesn't matter what it stands for, right? No one cares. It starts with 169.254, right? That means it's Windows default IP address, right? So if you get an IP address like this, that means it's most likely DHCP server has failed and there's a problem, and you need to go and sort it, because if you don't have DHCP, I wish you luck with networking, because you're gonna have a hell of a time fixing this stuff by your hand, because if DHCP fails, unless you have another system, which is a possibility, obviously, everything's a possibility. You can have a program, I don't know, requesting an IP address through, I don't know, a web server, whatever, right? There's millions of possibilities. Don't underestimate programming knowledge, and don't underestimate IT specialists, right? That everything's possible. So basically, DHCP, if DHCP fails, that means if every computer doesn't have, basically the network fails. The reason, because the IP addressing, yeah, they might be all connected together, technically not, but you cannot administer any of these computers. I mean, you can actually, sorry, you can administer them, but you cannot, they're not connected together, right? At least that's what I think. Let me just actually check. No, they're not connected, because there's two different IP addresses. Yeah, so basically now, because obviously they have a different IP address and it's not the way we wanted, we wanted to use DHCP and connect it to basically our servers. Also, if it's not, like, doesn't have an IP address, it's sort of a problem, because then if you want to administer it, connect to the computer, you're gonna have a problem unless you can connect through a MAC address, which I think it's possible. Right, so so that's why we should have DHCP. DHCP always is a good system, because if, for example, as I said, if you want to connect to this computer, you can just use an IP address. As you can see, we just need to go back and turn the DHCP on, and everything will be fine. Now, so as I said, switches are because we can go to switch, and we can have, as you can see, this is a switch, right? It has about, fuck knows how many ports. Yeah, so it has if I'm not wrong, it has 24. Yeah, so it has 24 ports, as I said. So you can connect 24 individual devices to this switch, just one switch. That means if you have a network of 15 computers, you'll need one switch, which is cost efficient, right? Switches are about, I think, 1,000 between, I'm not very sure, I don't know. You shouldn't really use any someone else's devices. For example, you shouldn't buy used, because the reason is because there could be some viruses in it, right? People could change stuff, and because obviously only businesses use switches unless you have a very, very big network at home. But the thing is, if you use a switch at home, like a Catalyst to 9060, for example, you will be, someone will target you anyways, because that means you're rich. Because I don't have a switch to 9060 at home, right? The reason is, yeah, I'm broke, whatever. So that's, yeah. Now, what happens if you want to basically connect these two networks together? For example, I have let's say this is the example. Let's put a label on. Let's put this as finance, and this will be HR, right? That's like the basic example of skill examples. Human resources, right? For people who don't know what HR stands for. So human resources and finance. We want to connect these things together. So what you would use is called something a router. Now for this case, I'm gonna use, I think it's this one has three faces. Yeah, so this one has 3 faces. That means we can connect 3 different routers together, right? So what we're gonna use is a cable. Now I'm gonna use automatic because I'm not very, very good with cabling. And as you can see, this is us sort of done. We're halfway through. We just need to set up a couple of things. And what I need to do now is set up a different DHCP server. Basically the same example as from our last example. It's just I'm using a different file. I don't know why. And now we should get different IP addressing. I need to change the server IP address as well. Remember, whenever you have you cannot have the same devices using the same IP address, right? So we need to always remember about this and change the IP addressing. I usually, whenever I set up one networks, I keep the first 10 IP addresses reserved for myself, so I can set up the switches and stuff like this. Now you can actually set IP addresses for switches, which I'll show you in a second. You can actually do this. I just need to remember the correct sort of command, hopefully. Okay, so they should have a different IP address now, hopefully. Yep, so as you can see, they have a different IP addressing, and we can change the IP addresses of these computers. There we go. So now what we need to do now is, because we set up the default gateway and stuff, so what we need to do is go router, config, gigabit internet, turn it on. Remember to turn it on, right? This is the most important thing. As you can see, this is a MAC address. IPv4, so 192.168.11.1. Second phase 192.168.21.1 and 255.255.255.0. Now, how did I get this IP address? Oh, because it's never turned on. And there's one more thing we need to do, VLAN, which we will do right now. So we need to do is int VLAN 01 no shot, and just quit or exit. So okay, and this will actually allow us, this is our both networks connected together. And let me just speed up the time. There we go. So this is our both networks connected together. Now I showed you this because I want to understand you how to connect two networks together in Cisco Packet Tracer. In real life it would be basically the same thing, because Cisco Packet Tracer is structured on obviously the reality, but obviously in a computer, which saves you obviously money, because I can set up a multi-million network right now without paying anything and without any experience, and you can learn stuff. So as I said, routers are used for connecting two devices together. Sorry, two or more. The maximum I think one router can handle is 4 networks at a time, right? That's how we do. You can also expand the routers. Now, for some reason, I would show you this, but it doesn't really work. I tried to make it work, but doesn't for some reason. You would basically what do is go at the back, you would go physical, zoom in, and use this. This is the HWIC 1GE 1 gigabit Ethernet SFP, and you would connect this together. Obviously, you have to turn it on. Now, turning the router off is a very, very bad thing. The reason, if you connect the router, if you disable the router, or like loses power, you have to connect everything together again. You have to set the IP address again. At least that's what I had to do when I was disable my routers. Actually, I'll show you. I'm gonna show you on a test run. So we're gonna disable it, and we're gonna turn on again. And in a second, it will take, as you can see, as soon as you go to CLI, which is the command line interface, it will take a second to connect. And as you can see, all the IP addresses are off, which is very bad. You can obviously encrypt this router as well, which you would have to go back to my tutorials from like I think it's the fourth video when I was showing how to configure switches and routers. That's how I show you to encrypt this stuff. So we need to obviously need to set up this again, so just do it quickly. And let me get router. Just press enter. You don't have to set the IP address subnet mask by yourself. And there you go. Now, as you can see again, so PC command prompt ping 192.168.21.10, and you should get a reply on the second. In a second, you should get a reply. Now, it might not work because the VLAN might be turned off, which is a high possibility. Yeah, it's down. VLAN's turned off. That's why we cannot turn it on. So interface VLAN 01 no shut, which means no shutdown. And now we should get a reply. Let's try again. The first request might be a request timed out, which is quite normal. But as you can see, we get a reply. That means this computer can communicate with, I think it's this one, that has the IP address of 10. Right. So basically, this is the basics of networking, right? I know I'm sort of showing you the same thing I showed you in the last videos, but I want you to understand this and want to get your practice, and so you understand networking and the basics at least. What else I wanted to show you? Now, what you can actually do is set up the routers by using the command line, if that's what you want to do. What you just have to do is, I'm just going to disable this, hope it loses, never mind, that's fine. So we're going to use is exit, right, enter en, which stands for enable, conf t, configure terminal, and we need to do is int gigabit Ethernet 01. There you go. Now that's what you need to enter. This needs to be structured. If you don't know how to, just go to gigabit Ethernet 001 and it'll actually enter for you, as you can see, interface. And what because is IP address 192.168.21.1.255.255.255.250, and it'll change the IP addressing for us. And let's go back to the PC. Hopefully I've entered the right thing. If not, that's okay. It will still work. Yeah, as you can see, we're gonna reply, which means I've done it the correct phase. Now there's 25% loss. Now that may be, no, never mind. It's just, as I said, it's just a bit. What did I want to say? No, it doesn't matter. Right, what happens now if I was to take this switch and change it with a hub? Right, so let's get a hub. Hopefully I can connect hubs with routers. Should be able to. Right, let's just connect. As you can see, we're getting a connection straight away. There we go. Oh, I think because this time sped up. Okay, so let's try now do the same thing, right? Because they should lost the IP addressing. It's fine. Just change it. Now I lost because obviously I disconnected the server. It's not gonna work because I disconnected the server. There we go. Sorry guys. There we go. There we go. Now it should work. Let's check the server. Yep, there we go. So let's do the same thing. Let's connect the again. As you can see, we're gonna reply. And as you can see, there's not really a big as I was actually expecting the lows to go a bit bigger. Time, let's say, yeah, time is the same as a switch. Maybe because there's just a very small network, maybe that's the reason. But overall, hubs are much slower than the switches. Because, you know, hubs operate on IP addressing and switches operate on MAC addressing. MAC addressing is faster because switches actually basically they know where everything is, and IP addressing it's not as fast, because what has to happen is, for example, if I send data through this computer, it basically goes through the switch, it goes immediately to the router because the router operates on MAC addresses and it knows where to send exactly. It doesn't have to go like, oh, is it you? No, it sends directly from the router to the hub, and now hub is a bit slower because it has to recognize where the fuck does it has to go.